So today we're gonna solve problems on exceptions in Java. So first we have a file handling. Write a method that reads a file and handles file not found exception and input output exception. So let's write a method. So public static void. So how do we call this method? Read file. Let's say we have a path, string path, file path. Okay, let me say file path. Then here I'm gonna create a string line. And we're gonna save the file path to our file class with the type, let's call it file, new file, new file reader. Here we'll put our file path. Alright, then let's have a try catch block. Try buffered reader, let's call it reader, new buffered reader. Actually here we should have this new file reader. This is a file. Here we should path a file path. So file path, file reader. We'll try this. So basically exceptions are the errors that occur during the execution of the program, and to handle the exceptions we can use the try catch block. So try, let's move the string inside our try block. String line. So while reader dot read line, and we should make line equal to this. So while this is not null, does not equal to null, while line reader dot read line does not equal to null, we will keep printing out the line, and should have a catch block here. So catch, let's start from input output exception, and let's give it, let's call it E, catch input output exception, and print out some message. Input, and let's say IO exception occurred, and let's say caught. Alright, and another exception, let's write another catch file not found exception, and we'll print out file not found. Okay. So we should move this, should put this before this exception. So here. Like this. see what we got. It's in the main method, let's say read file. It's called the method read file, and the path, say example.txt, which does not exist. And let's run this. So it says file not found. Alright. Now let's move to the next task. Input validation. Create your own invalid input exception that is thrown when an invalid value is entered, such as a negative number. So first of all, invalid input exception. Is it going to be checked or unchecked exception? Let's create our own exception. Let's create a new class. How do we call this? Invalid input exception. Okay. So to create our own exception, we can basically extend the class exceptions or runtime exceptions if we want to have an unchecked exception. So invalid input, this is going to be a runtime exception, so we will say extends runtime exception. Right, and now we need to specify the constructor. So let's generate the constructor. Okay, let me write this. Public invalid input exception. And in the parameters, we should pass the message string message, and we'll call, and we'll pass that message to a parent class, so super message. And this keyword super allows us to refer to the parent class, meaning to class runtime exception. So here is the message. Alright. Now, what else do we have? Create your own invalid exception that is thrown when an invalid value is entered. And now let's create some method. Okay, let me create some methods. Public, let's say static void. How do we call this? Input value, let's say input value. Say some kind of an integer. So integer value. And to indicate that this method may throw an exception, we can use the keyword throws invalid input exception. Now so within the method we will have an conditional if statement. So if value is less than 0, so if value is less than 0, then we'll throw an invalid input exception. So new, so throw new invalid input exception that will print out the message. Invalid input. Negative number. Okay. And else we'll print out valid or valid input. And let's rename this method. Let's call it check input. And actually we don't need this else. We can just leave this message. So if the value is greater than 0, then this part of the code will be ignored and it will print out this message. So we don't need else statement here. Now let's see. Let's check what do we got. So check input. Let's say -1. And let's run this. So it says invalid input. Invalid input. Right. And let's say just run. What will we have? Valid input 1. Correct. So now let's move to the next task. Implement a method for dividing numbers that handles arithmetic exception if division by 0 occurs. Okay. Now let's implement a method for dividing but before that let me get rid of this. So we're asked to implement a method for dividing the numbers that handles the exception division by 0. Let's go and do that. So public static void, how do we call this method? Division, let's say some division. Divide, let's call it division. So division that accepts two numbers, let's say double A and double B, and we can use the keyword throws to indicate that our method can throw an exception. Throws arithmetic exception. And now within the body we say if A divided by 0 or B is divided by 0, then we will throw an arithmetic exception. So throw new arithmetic exception, and we will say division by 0 is actually the division by 0 is illegal even in the compiler, I mean even in the IDE, so let's simplify this expression. We need to check only the denominator, so the denominator should not be 0 if denominator, so in case this is b, is 0, then we'll throw an arithmetic exception. And let's specify the return type double, and we'll return a divided by b. Now let's check, let's test our method. So division, let's say 1 and 0. Now we should get an error, or the message division by 0 is illegal. Yes, we get the message division by 0 is illegal. So now let's try a legal operation. And we should print this out. One more time. 0.5. So it's correct. Now let's move to the next task. Write a program that prompts the user for an array index and handles array index out of bounds exception. So let's write our method. Public static void, how do we call this method? Let's say check index so index is an integer, let's say integer a, let's say integer index, and let's indicate that our method may throw an exception using the keyword throws array index out of bound exception, index out of bound exception. So let's first create a list, a list of integers. Let's call it list, new array list. And we can use method list of to directly pass the elements to our list. So let's say 1, 2, 3, and we can import the class list. And let's specify our array as well in the parameters of our method. So list of integer. So what do we do in this case? We call the method check index, pass our array and the index that we want to check. So this array has indices 0, 1, 2, let's say 3, which is illegal. Now we need to handle this. So we have a conditional, let's have a conditional statement if. So if the size of the list dot size -1 So list size -1, if that is less than the index, then we will throw a new exception, new array index out of bound exception, and we will say index does not exist. Else we can return the element from our list. So list dot get the index, and here we should have a return type integer. Now let's check. Now we should throw an exception. Index does not exist, right? So if we say 2, then it will return the element 3. We should print this out to see. Let's run again. So this is 3, now it's correct. So the next task is to create a method that throws one exception but catches it and throws another exception chaining. Okay, let's get rid of this. So let's create our custom exception. First, custom exception. So custom exception extends exception, and it will have a constructor public custom exception that has string message and string calls, and we'll call super and pass the message and calls. But instead of string, it should be throwable, and now we call the constructor of the class throwable. So where is the constructor of class throwable? So here we have string message, and string calls. So calls is the cause which is saved for later retrieval by get cause. So we can use the method get cause and get message to print out the detailed information about the exception. So let's go back to our main method. Now we created our custom exception. Let's create a public static method, public static void method A will have a try catch block, so try method B that we'll specify later. Let's specify it right now. So method B will throw an arithmetic exception. So public static void method B, and it throws new arithmetic exception, division by 0. When we call method B, we want to catch that exception, catch arithmetic exception, and here and when we catch the arithmetic exception, we'll throw another exception, so throw new custom exception, and here we should pass the message. Let's say exception in method A, and the cause is E. And we should also indicate that our method throws custom exception. Alright. Now we have method A, method B. So this is called chaining, when we catch one exception and call another exception after we caught that exception. So let's test our exceptions. So let's say try method A and catch custom exception and print out the message. So e.getMessage and e.getCause. GetCause. So let's say cause, and this is the exception. Let's run and see the result. Exception in method A and cause division by 0. So this is the chaining in action. Now let's write a method that throws multiple exceptions: null pointer exception, arithmetic exception, number format exception, and handles them with different catch. So this is a multiple catch exception. So let's create a method, public static void, and let's call it risky method. And here we will have string, let's call it s, some integer divisor, and another string, let's call it number. So we will say if our string is null, then we will throw new null pointer exception. Then let's have some integer text, and let's say our string number, or no, we'll use integer.parse, parse integer. So we'll parse this string number into text, but we'll pass a string instead of a text. And for the divisor, let's say division, and let's divide by the divisor. So now let's go to our main method and write a try catch block. So try our risky method with the arguments null, divisor 0, and string ABC, and catch the null pointer exception. Let's print out caught null pointer exception, and get message to print out the detailed description of the exception. Now the second catch block, number format exception. So because of the mismatch, the ABC cannot be converted to an integer. We can catch the number format exception, print out caught number format exception, again get message. And the last but not least, catch arithmetic exception, and we'll print out caught arithmetic exception, and get message. So let's try to run this. So our first exception is null string that throws null pointer exception, which will be caught here in our main method. So as you can see, caught null pointer exception. Let's say our string is not null. Now it will throw an arithmetic exception, a number format, yes. So instead of an integer, we passed the actual string, which cannot be converted to a number, to an integer, so it caught a number format exception. Okay, let's fix this. Now we have divisor 0, which will cause an arithmetic exception. So we cannot divide a number by 0. Divisor cannot be 0. Okay. Now let's implement a method that takes a string and converts it to a number, handling number format exception. So we need to use the parsing. Right, let's remove this. Let's create our methods. Public static void. How do you call this method? Parse string. So it takes up a string and converts it to a number. So string s. Now we want to have integer integer number is equal to we use method integer dot parse integer. We pass our string and we wrap this around the try block. So try this and catch number format exception and print out this string or your string cannot be converted. Let's say s. Okay, now the return type should be integer. Here we'll convert, we'll return this, and in worst case we'll return 0, which is false. So now let's go and create our result. Let's say string test. Let's say ABC, and then print out test, and before that we'll call actually let me take this parse integer. We'll call parse integer and we'll pass ABC. It should be integer. So now we should have an error. Not exactly an error, but the message that you cannot convert the string. So it says your string cannot be converted. And if we say 1, 2, 3, then we get 1, 2, 3. So correct, everything works. If we say 1, 2, 3a, then it again will crash because we cannot convert a to a number. Alright, now let's write a method that opens a file and reads data using try with resources to ensure that resource is closed. So we need to use finally. We need to use a method. We need to use try catch block with the finally in the end. So let me remove this. So let's create a string that will contain our file path. So file path, let's say example.txt, and now let's create a method, public static void file reader that accepts the path, file path, let's just call it path. And here let's have a try block, try, within parentheses we pass the buffered reader. We create an instance of class buffered reader. Let's call it reader. new buffered reader, and here create new file reader and pass the path. Okay, so now we open the curly braces. We should import file reader. Now within a try block, let's create a string line, and while reader, or let's say line, is equal to reader dot readLine does not equal to null. So does not equal to null. We will keep reading that line. Okay. Now we catch input output exception and print out the message cannot read file path. Okay, so this method, specifically this part of the code, allows us to use a try with resources that automatically closes the buffered reader, so we don't have to manually go and say finally reader dot close. Now instead of that, it will automatically close the files for us, and this way of writing the readers is recommended. So now let's call our method file reader, pass our file path, and run. Cannot read file example.txt because it does not exist. Let's say e.getMessage, e.getMessage. The system cannot find the file specified. So now let's move to the next task. Implement a method that prompts the user for a number but does not accept null or an empty string, throwing an illegal argument exception. So let me remove this and this. Let's create a method, public static void, that prompts the user for a number. Input number. It's integer number. Parameters integer number. Actually, let me rename this. Let me write it again. So public static void Actually it should be integer since we return a number, and let's call it get valid number. Nothing in the parameters since we will be accepting the input through the scanner. Now let's create a scanner, new scanner, and let's create a variable of type string input, and our variable input will store the input that we accept from the user. So scanner dot next line dot trim to remove the trailing spaces. Here we should also specify system in, and now let's print out the message. Let's say enter a number, and let's throw an exception, invalid argument exception, if the input is empty. So if input is empty, we will throw new illegal argument exception, and let's say input cannot be empty. And now let's let's write a try catch block for our return statement. So try to return integer dot parse integer, parse our input in case it's a string. So parse it and return as an integer, and if we have some illegal arguments, again we'll catch that. We'll catch illegal argument exception, and we'll handle it by throwing new illegal argument exception, and we will say invalid input. e.getMessage. Now let's try to test our method. Let's print out get valid number, and now let's run this. So let's enter some number. Let's say null. It says invalid input for input string null. So it caught our exception, so we threw the exception here. It cannot be empty. Now let's try one. Let's try 1 2 3. 1 2 3 printed, so it's valid. Now let's try semicolon 1 2 3. I mean the quotation 1 2 3 quotation. So it says invalid input. Invalid input or input string 1 2 3. Alright, let's try one more. I'll leave it blank, so input cannot be empty. Okay, correct. Now let's write a method with try catch finally, which finally is executed even if there is a return inside the try. So let me remove this and this. Let's say try to print out try block, and then let's say finally print out final block. Finally, final block. Okay. Or let's say program terminated. So the both messages should be printed because the block finally executes regardless of whether the try block returns something or not. So now I can even write some exception. Let's say catch arithmetic exception, and I will throw new arithmetic exception, and I will say division by 0 e.getMessage, and here let's divide by 0, 10 divided by 0, and then we have our finally block. Finally, so it will try to divide 10 by 0, then it will throw division by 0 message, and this line will be printed out in the end. So here we have program terminated and division by 0. Alright. Now let's move to generics. Create a storage, a class storage, a generalized class or generic class storage that stores an element and returns it. So let's go to, let's create new package, generics, and let's create a new class. How do you call it? Is storage. Now to make this class generic, we can use these angular brackets. So generic classes are useful when we need to work with different data types. So this allows us, this provides a flexibility. So let's say we have a storage, and let's say we have some private t element of type t, and let's create a getter. I'll quickly generate getter and setter. And constructor. So now let's write a main method and create an instance of class, or generic class, storage. So let's say string storage, new storage, and here let's say book or something like that, and let's print out system out string storage get element. Now let's run this. So we have book, right? Now let's implement a print list, a generic method print list that uses a wildcard, takes a list of any type and prints its elements. So let me remove this. So let's start. Public static void print list, the name of our method. Print list. So here we pass a list with an unknown type, so wildcard, list wildcard. Now we can import the list. Let's call it just list. And to traverse and print out the elements of the list, we can use either a for loop, so for each object, for each object element, we can print out the list and get the element, separating them by spaces. So we can try either this method, or I will show another one later on. So let's create a list of integers and let's call it list, new array list. Let's directly pass the values, so list of 1 2 3 1 2 3 4 5, and let's call our method print list, print our list. So here you can see 1 2 3 4 5. Here I used the type of the element object because object is a parent class of all classes in Java, and storage by default is also an object. So you could either use this method, or I could use iterator, which we also need to import. Iterator, let's call it iterator list dot iterator, and then what do? We have an infinite while loop. So while iterator has next, we will print out iterator next. Alright, so let's see the results. Let me separate them by spaces. So this is it. 1 2 3 4 5. And we could use a string as well instead of an integer, and pass a list of strings. So string apple, orange, watermelon, and this would work perfectly. Apple, orange, watermelon. So that is the purpose of the wildcard. It allows us to work with different data types. So in advance we don't know the type of the list, and whatever we pass, I mean, we could have a boolean or whatever. Boolean, let's call it true false. True false. And it would work. You can see true false. We can get the class of our list, get class. Let's see. Class array list. Alright, let's move to the next task. So create a number box that is upper bounded with the class number, and that stores only numbers and returns their sum. Alright, let me remove this. Let's rename refactor. Rename our class. Let's call it number box. So number box refactor. Now let's make a generic class. So of type T, and it extends numbers. Number, yes. So this number box will store only numbers, and it will return their sum. So we have a private list of type T. Now let's create a constructor. So public number box, let me name this list. So list is equal to new array list. Alright, now let's add some methods. Method add, public void add number, or let's just say add. So add integer num, and we add it to our list. So this list dot add number, and of course it should be of type T because our list is not an integer, it's a T. And let me rename our list, let me call it numbers. Numbers. So, and it should also be able to return their sum. So public double get sum. So let's say we have a let's create a variable. Let's initialize and declare a variable sum, and let's use a for loop for each number, for each double number in list or in numbers. We want to make sum plus or equal to, we want to add numbers to our sum. Add numbers, and it should be of type T. And in the end we'll return sum. Let's initialize our sum. And our num should convert it to a double value. So num double value. Now let's create an instance of class number box. So number box of type integer. Let's call it a number box. New number box. Let's add elements. Let's add numbers to our number box. So add number box dot add 10, 15, 18, 23, and now let's print out their sum. So sum. We'll call the method getSum. Alright, let's run this. So 10, 15, 25, 25, 35, 43, 66. Yes, correct. Now let's move to another task. Write the generic method that takes a list with an upper bounded list and computes the sum of its elements. So we should create a generic method that takes a list and computes its sum. So let's create a generic public static let me remove this. Void compute sum. So we pass a constrained list with a wildcard that extends the class number. So the elements of our list can be, it is bounded by the class numbers. So it's an upper bounded wildcard. And let's call it numbers. And let's create a variable double, let's say double sum 0. Now we want to iterate over the elements of our list. So for each number in numbers, we want to add up. So sum plus or equal to number double value, and in the end we will return the sum, and the return type is double. Alright, now let's run this. Let's create a list of integers. Let's call it integer list, new array list of, to pass the arguments 1, 2, 3, 4, 5. And let's create another list of double. So double, let's call it double list, new array list 10.1, 10.5, 13.4. And let's print out print out the sum. So sum of integers. Let's call our method getSum, compute sum, and pass our integer list, and the same for our double list. So sum of doubles and compute sum double list. Now let's run this. So we get sum of integers 15, 1, 2, 3, 4, 5, 9, 12, 14, 15. And here we get 10, 10, yes, 34. Correct. Let's move to the next one. Lower bound. Implement a method that takes a list with a lower bound. So wildcard super integer means that the list can have elements of type integer, or it is superclasses, and add some numbers to it. So let's implement our method public static void. How do we call this method? Let's call it integer list. So list with a wildcard, a lower bounded wildcard. So we use super integer. Let's call it list. So it takes a list and adds some number to our list. So let me remove this. So we take our list and add some numbers to it. So list dot add, let's say 10, 20, 30, let's print out numbers are added successfully. Successfully. And let's call our method integer list. So integer list and let's pass our integer list to, let's actually rename this. Let's add let's say add numbers, and then print out the updated list. Integer list. Okay, what do we have? So numbers are added successfully, and then we can see 10, 20, 30. So if we were to add some double number, then it would be incorrect because our list is lower bounded. So it can have the elements of the class integer, or its superclasses. So integer extends number, implements serializable. So it can either be integer, long, float, double, short. Like I said, when we use super, super is super indicates that we can add, like at least can contain elements of type integer or its superclasses. So double is not an integer, says that's why we're gonna have a compilation error if we try to run this. So it says incompatible types. That's why we can add integers, numbers, or objects. Those are the superclasses of the class integer. So it could be either a number, so this would work anyway, or it could be an object, and this would work. So that's why. But if we didn't have this super, and I would say just integer, then you can see that number and integer, they're not equal, and this would cause a compilation error again, incompatible types. So that's why we need this super keyword in this case. Alright, now let's create a container, a generic interface container that contains add, t-item, and get methods. Alright, let me get rid of this. Let's actually create a new class. So let's create a new class. Interface, how do we call our interface? Container. So container with the type T, contains add item and get methods. So let's create an interface. We call it container. So container of type T. We use generics. It's a generalized interface, and we're asked to add method add and get. So void add t item and method get. So t get alright. Now let's create another class. Let's call it box. So box with the type T that implements our container with a type T. And now we need to override the methods of the container, which is add and get. So let's create a private field, private t item. Let's generate a constructor and So we have method add, void, let's say public void add t item, we set this item is equal to item, and also we should implement get, so public get of the type t, get return this item. And actually we don't need this constructor. So now let's test what we got. So box of type, let's say string, call it string box is equal to new box, and let's add some items to our box, to our string box. So let's say okay, apple, book. Oh, it's not a list, so let's just add an apple. And let's get our item, so string box get. So as we can see, apple. And we could also have another type, we could have an integer here as well, so integer, or at the same time, let me print this. Let me copy this. So integer type integer box. Now let's add 1, 2, 3 int box. And we'll print out 1, 2, 3 and apple. So this box can store elements of different types. As you can see, apple and 1, 2, 3. So now let's create a map with the key value pairs and implement a method that takes the generic keys and values and then prints them. Alright, let me get rid of this, or let's create a new class. Let's create a class collection, and let's a generic collection. Generic map. So let's create a map. Let's create a method. So public static void with the name. How do we call this? Print map. And here we should specify the key value generics. So key value, here we pass for map, the key value, map key value, and of course we import map. Let's call it map. And then what do? We go into a for loop for each map.entry, of course with a capital, entry key value, map.entry key value, let's call it entry. For each entry in map.entry set, entry set allow that it returns all the key value pairs. So now we have access to keys and values. So entry.getKey plus entry.getValue. So this will print out all the key value pairs. Alright, now all we need to do is to create a map. So let's say a string. Let's create a map of type. The key type will be integer and the value will be string. So let's call it map1. So new hash map. Let's add some numbers. Map1 put, so 1, let's call it John. Two, Alice. 3, James. And then let's call our method print map. So print map1, and let's see what we got. As you can see, everything works correctly. Now let's change the order. The first will be string, the second will be integer. So string, and the second is integer. So John 1, Alice 2, James 3. So let me use the class box. So we're asked to extend class comparable. Let's extend comparable. Alright. Comparable T. So it stores an object and compare it with another object. So let's create private T. Let's call it value. Let's create a constructor and we want to be able to compare. So there is a method compare to that we should overwrite. Let's overwrite the method compare. So public void actually returns integer compare to so compare to box type T, generic box, let's call it other, so we return this value dot compare to other. Since other is a box, we should convert it to type T. We can use other.value. So this will return either 0 if they're equal, if the value is greater than, the value is greater than other, then it will return positive 1, if not, negative 1. So let's also overwrite the method toString. I will generate that toString, and now we can try to create an instance of class box. Let's call it integer, say box1, new box, so let's say 10. Let's create another box. It's called box2, and the value will be 100. Now let's give it 10 for now, then I will change it so that we could see the different versions, different variations of the results that the method compare to returns. So now let's print out box1 dot compare to box2. So this should be 0 because they're equal. Now if we make the first box greater than the second box, then it should return positive value, so it should return 1. Means the first box is greater than the second box, and if we say the second box is greater than the first box, then the negative value will be returned, so -1. Alright, what else? So we can go to class, to wrapper integer. We can see that it implements comparable, and it should have a method compare to. So it has a method compare to that compares this value to another value. So when we call this method compare to, depending on the type of the box, those values will be compared. So for example, if we say double here, then what will happen? Incompatible types, so they both must be of the same type. So if we want to compare the double values, then they both must be double, like this. Now we can compare them. minus 1. So now let's move to the last task. Implement a generic class pair with generic key value that stores a pair of values of different types. So let me create a new class, pair key value. So it's a generic class that will allow us to store the objects of different types, the pairs of different types. Now let's declare our fields. So private key of type k and private value of type v, or generic type v. Now let me generate a constructor. Also, let me generate a method to string. And let's generate the setters. Okay, getters and setters. Alright, now we have our generic class pair that can store the key value pairs, generic key value pairs. So we can create a pair of type string and integer. Let's call it pair 1, new pair. Let's say h, key h and value 25. Let's create another pair. Let's say boolean, and let's say double. So we can use any wrapper because our class is generic. So let's create a key value pairs. Let's say true. Let's say 99.9. So as you can see, we have string integer pair and boolean double pair. So we can print out this pair 1, pair 2, and it should work. So as you can see, pair key h 25 and key true value 99.9. Alright, so this is our last task. Generic pair, the generic class, the pair, it stores a pair of values of different types. So yes, this is it. Thank you for watching, and I'll see you in the next one.